we are moving on to the second rule of 5 for exponent expressions. And the first rule was called multiplying by the same base. And so today we're going to be dividing by the same base. Okay? When you multiply by the same base, your hint to know that's what was going on. If you look back at CO10 here, you see a whole bunch of multiplication signs. Right? That's how you know you're multiplying by the same base. How you know you're dividing by the same base is you see a bunch of
division symbols
written as fractions. Okay, but essentially yes. All right. So these expressions kind of give you hints, give you clues as to what rule you should be using when you see a fraction. You're thinking dividing by the same base because a fraction is really just division. So just like we did in CO10, we're going to write these out in expanded form so we can see what's going on here. Okay? And then from there, develop a rule, and then we can use that on the homework going forward. So the first one here, 3 to the 5th times 3 squared. The numerator, 3 times 3 times 3 times 3 times 3, and our denominator is 3 times 3. Now notice how I wrote this. I wrote this a specific way for a reason. I didn't just put my 2 3s in the bottom in the middle. I put them directly below 2 3s in my numerator. The reason why is because there's an algebraic rule that you've all heard before. Anything divided by itself equals 1. Think of when you've simplified fractions before. If you have a 3 in the numerator and a 3 in the denominator, what can you do with those? You cancel them out because 3 divided by 3 equals 1. Okay? What can we do with this pair of 3's here?
Cancel them out.
Cancel them out. Right?
Oh.
And so, folks, what we're left with are how many 3's where? 3 3's where? Numerator or denominator?
Numerator.
The numerator. And so our answer to this is going to be 3 to the 3rd power. Okay? 3 to the 3rd power. Our denominator is gone. If you want to write it over 1, then you can. But you don't have to. Right? Because if something's over 1, we don't have to write that over 1 part. Lucas.
Couldn't we just write the answers as 3 to...
In this part, you need to write it in expanded form. Because we're
saying
seeing...
3 to the 3rd power is a solvable.
Oh, no, you would leave it as 3 to the 3rd. Yeah, yes.
I know we're probably going to get to it, but can we also cancel out the x's and z's?
We're going to get to it. Your prediction was absolutely correct.
I knew it.
Okay. Number 2, again, writing in expanded form. In our numerator, we've got 6, and then x, 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 4 of them, and then 2 z's. In our denominator, we have a 3 as a coefficient, 2 x's, and 3 z's. And again, notice how I'm intentionally writing this out. Okay? Putting my x's beneath other x's, my z's beneath other z's. Because as Peyton correctly predicted, just like how 3 divided by 3 cancels out equals 1, what's x divided by x? 1. Because whatever x is, you're dividing it by itself, that's going to equal 1. So this pair of x's can be canceled out. And so can that pair of z's. So we look at what we're left with now. Well, first of all, are we done simplifying? Anyone else see anything else that we can do? Olivia?
Wait, can we divide the 6 and the 3?
Very good. Yes.
Oh, you divided it.
Shh, your outbursts are not welcome.
Okay.
You can divide the 6 and the 3. The common mistake that folks make here is they subtract them. But remember, this is a fraction. The fraction 6/3 can be rewritten. I'll do it in red as 2 over 1. Okay, 6 divided by 3 equals 2. The fraction 6/3 is the same as 2 over 1. So what we're left with in our numerator is we have our coefficient 2. And how many x's? 2. Any z's?
Yeah. Yes.
In our numerator?
No.
No. So our numerator is only 2x squared. All z's have been canceled out. Why? Because we had two of them up top, both of them were canceled out by taking z divided by z, so in our numerator there are no z's remaining. Because they're both gone. We cancel them both out.
It's still a new.
Okay? Yeah, Lucas? So in our denominator, we have this coefficient of 1, which we can write if we want to. We don't have to. Just because we're still learning, I'll put it in there. Right? 6/3 becomes 2 over 1. In our denominator, do we have any x's? No. We do have, though, 1z. And so our final answer is 2x squared over 1z. Because after canceling, we had 2 x's left in our numerator. That's why they're still up there. They didn't cancel out. In our denominator, we had 1z left. Did not cancel out. Yeah?
Why do you write your z's like that?
Because I was told many, many years ago that writing my z's like this looked like a 2, even though every 2 I've ever written looks like that. But because I'm an accommodating teacher, the students said they couldn't tell if that was a 2 or a z. I decided to go like that. Yeah.
You can change it back now.
Okay.
You can change it back now.
The last one. 9m to the 4th over 12m. Again, thinking about expanded form here, our numerator is going to be 9 times m times m times m times m. Our denominator is 12 times m. What can we do here? What can we do? Jude?
Cancel out one of the m's.
Cancel out one pair of m's, because anything divided by itself, even m divided by m, equals 1. What else can we do? Henry?
Can we divide the 12 from
Yeah, what is 9/12?
3?
Simplify to be 3/4. Just the fraction 9/12 becomes 3/4. This is a fraction, so you wouldn't divide 9 by 12 to get a decimal. We divide it here because 6 divided by 3 works out evenly, right? But 9/12 doesn't, therefore we simplify it as a fraction. So now what is left? What's left in our numerator? James?
The 3 m's.
Coefficient, our 3 m's, and what's our coefficient?
3.
3. So our numerator has a coefficient of 3 and m cubed, because there are 3 m's that were not canceled out. Right?
Yep.
What's our denominator? What's left?
4.
4. Any m's?
No.
No, because the 1 m we had canceled out. There aren't any left. And so 3m cubed over 4 is our final answer. Okay? Now, as critical thinkers, as mathematicians, we don't want to have to write expanded form out all the time here. Okay? It's tedious. It's good to understand it, but the rule is much more efficient. So take a look at what we did. What did we do with the coefficients? What did we do with the exponents? What did we do with the bases? So instead of having to write this out in expanded form every single time, we have this rule to look at. Grayson, what did you see?
The coefficients, they get divided.
Divided, I'm going to go with simplified, because I don't want you to be dividing 9 by 12 and putting that as a 0.75, so they get simplified, right?
Exponents get subtracted.
Exponents get subtracted. Let's just pause here for a little bit. Okay, let's test this out here. 3 to the 5th over 3 squared. We ended up with 3 cubed. It's not a coincidence that 5 minus 2 equals 3. Right? Because if we have 5 3's in the numerator, 2 3's in the denominator, these 2 3's will cancel out with 2 3's in the numerator, leaving us with 3. 5 minus 2. Over here, x to the 4th over x squared, 4 minus 2, we ended up with 2. This one, those z's though, how do you know whether or not your base is going to end up in the numerator or the denominator? Like, how can you look at this and know that your x's are going to be in the numerator, the ones that are left, and your z is going to be in the denominator? What's your hint for that? Grace? Yeah, it's where you have more to start with. If you have more z's in the denominator to start with, when you do your subtraction, you're doing it from 3 minus 2. You're starting in the denominator because that's where your z is going to be left. Wherever you have more of the base to start with, that's where that base is going to end up. Right? And then lastly, remember, this is a power of 1, even though it's not written there. 4 minus 1 equals 3. And we know it's in the numerator because we have more m's in the numerator to start with. Okay? That's the deal with powers. Where do you have more to start with? That's where they're going to end up, and then you use subtraction. As far as the bases, what happens to the base?
Stays the same.
Stays the same. Stays the same. Again, we have that tricky little spot where our base is a number. Kids all the time want to write 1 cubed because they divide 3 by 3, but the 3 is not a coefficient, right? Coefficients do get simplified. 6/3, 9/12. That 3 is a base. The base stays the same. Okay? How we doing?
Good.
Decent?
Yeah.
Okay? For this section here, we do need to write it out in expanded form because I'm a mean old ogre and I require you to do that. But on the back side, you don't have to. And the back side, things, I mean, you don't want to write this out in expanded form, right?
I'll write it up in expanded
Oh,
form.
You do you, man. You do you. I don't want to do it. Okay. Here we go! First one, 9 to the 6th over 9 to the 4th. In expanded form, your numerator looks like this. 9 times 9 times 9 times 9 times 9 times 9. There are 6 of them. The denominator looks like this. 9 times 9 times 9 times 9. Do your canceling out. Anything divided by itself equals 1. So gone, 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 gone. And how many 9s do we have left, and where are they? 2 in the numerator. So if you want to leave it as 9 squared, then you can. If you want to write it as 9 squared over 1, that's okay. Right? But those 2 9s are in our numerator. Using the rule, 6 minus 4 equals 2. We have more in the numerator to start with. That's how we know that's where the 9s will be in the end. And then 6 minus 4 equals 2. 9 is a base, not a coefficient, so it doesn't change, doesn't become a 1, stays 9, and there's our final answer. Okay? C to the 5th over c squared. C times C times C times C times C over C times C. You see what I'm doing here?
Yeah.
Get it? Okay. Anything divided by itself equals 1. Cancel out 2 pairs of C's. How many C's are left?
12. Or 3. Or 3.
3 in the numerator. So if you want to put C cubed over 1, then you can, but you don't have to. Using the rule, 5 minus 2 equals 3. The base stays the same. Okay. What's a pirate's favorite letter? You think it'd be R, but it's the C.
No, it's
No,
not.
there are 3 letters.
It's
There are 3
what?
letters.
It's
It's
not.
C, R, and X.
Why would it be S?
X
And
marks
X
the
marks the
spot.
5.
No.
Pirate.
Let's do
I didn't
3, 2,
make this up.
1. You
Get out,
are
Everett.
quiet. Let's do the middle one and the bottom row together, then you can do the other 3 on your own, and we'll pause the video and go over answers. Again, writing in expanded form, 8 times x times x times x times y times y times y over 4 times x times x times x times x times x, an extra x there. Oh, we got a bunch of y's too. 5 of them. Y times y times y times y times y. Whole bunch of stuff. Okay? So here I didn't really line up, I didn't plan ahead very well. I didn't line up my y's in the numerator with my y's in the denominator. But I'm a smart man, so I can figure it out. Coefficients. 8 minus 4? No. What do we do with the coefficients? Simplify them. 8 fourths becomes what? 2 over 1. Okay? So I know that my answer is going to have a 2 in the numerator. If I want to put the 1, I can. I don't have to. My x's cancel, 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 cancel. How many x's do I have left and where are they?
1x.
Or where is it?
Denominator.
1x in the denominator. If I look at my original expression, I have 1 more in the denominator to start with. That's how I know it's going to end up there. 5 minus 4 equals 1. Wherever you have more to start with, that's where it's going to be in the end. And then for my y's, cancel that pair out. Kind of a funky cancel line, but there we go. Okay? I've got 2 left in the denominator. And so my final answer is 2 over xy squared.
It looks better with the 1.
Okay? Put the 1,
For real.
no problem. Right? The important thing is to know how many y's you've got and where they are. You've got 2 of them, you know where they are because it's where you have more to start with. I'm going to pause the video, we'll go over answers here, but just do the last 3 on your own sum. So here we go. 2 to the 8th over 2 cubed, expanded form, which you did need to write, looks like this. Sorry there are 8 of them there, but that's why we appreciate the rule. 2 times 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 2 over 3 in the denominator. We can cancel out 3 pairs of 2's, leaving us with 5 2's in our numerator, and it's not a coincidence that 8 minus 3 equals 5. If you put 1 to the 5th, your mistake was simplifying the bases instead of keeping them the same. Okay, there are no 1's up here, only 2's. Well, there are technically one's over there, but only 2's. It's not 1 times 1 times 1 times 1 times 1. Bottom row. This is one that likes to trip people up on tests. We have h times h times h times h and 7 in the denominator.
Oh, I did it wrong. I didn't know what I did.
You can see that you'll have 2 h's left over, right? Whether you use the rule or cancel them out. You've got 1, 2, 3, 4, 5 pairs that are gone. You've got 2 left. Where are they?
On the denominator.
In the denominator. So if everything cancels out in the numerator, what goes there?
1.
1.
1.
Has to be a 1.
Let's go.
When the denominator is 1, you don't have to write it. When the denominator is 1, you don't have to write it. When the numerator is 1, you do. Okay, 1 over h, and actually it should be h squared, not h. Sorry, 1 over, I'm so excited about the h being down in the denominator. 1 over h squared, because you have 2 of them left. Olivia?
Wait, so I put H like as 1 for the top. Would that be wrong?
It would be, because there are no h's left. Right? If all the h's cancel out, and you put an h up top, that means you can still cancel more out, so it's got to be a 1. Yeah?
If I put h squared, would that be right? Or would it be-
Just h squared, not 1 over h squared?
Well, I did 1 over h squared, but then I did it h squared first, and then I fixed it.
So h squared will be wrong. You have to have 1 over h squared. Yeah, when the denominator is 1, you don't have to write it. When the numerator is 1, you do. Okay? You do. Last one. In expanded form, 10 times x times y times y over y times y times y times y. Cancel out 2 pairs of y's just like that. In our numerator, we're left with a 10 and an x. In the denominator, we're left with y squared. Okay. Questions on, folks, questions on what we're doing? Your homework for tomorrow, the second page, here's my gift to you, Spirit of Christmas. You do not have to write these in expanded form. You can just go straight to the rule, right?
Otherwise, we would have been.
Kyle? Christian? Grace? I recommend, if the front page didn't go very well, I recommend still doing expanded form when it makes sense. This first one, not so bad for expanded form. I would definitely not do the middle one in expanded form. That would take too long. This one is okay in expanded form. But notice too, that bottom row, we're kind of combining CO10 with CO11, aren't we here? Okay? We're combining CO10 with CO11. Simplify the numerator and the denominator separately first. So you do that first. Then do your rule for the division. You do your numerator first here, your denominator second there, separately, and then combine them using CO11. So that bottom row, you've got CO10 and CO11 together. Do the CO10 rule first. You can, then the very bottom section, I'm giving you the answer. It's like Jeopardy style. I'm giving you the answer. You write me an expression you could have started with. So for example, if you end up with x to the 12th, what could an original expression have been? If this is your answer, x to the 12th, what could an original expression have been? Yeah.
X to the 11 plus 1.
Actually 11 times x.
X to the 11, yeah, times X.
So we are using this rule, CO11 here. Okay, you would be wrong, but using CO11, practicing this simplifying rule. Henry?
X to the power 7 times x to the power 5.
Again, using CO11, you are right, that would give you x to 12, but using CO11, meaning we're using fractions, we're using division, dividing by the same base. Claire?
X to the power of 14 divided by x to the power of 2.
Yes, there you go. That would simplify to be x to 12. Lucas, do you have another option that you came up with?
That's exactly what I was going to say.
Ooh, vibing with Claire, yes.
X21 over x.
X to the 21st over x to the 9th would be another possible answer, right? So I'm giving you the answer. You are writing a potential division CO11 expression that would give you that as a final answer. Okay? All right, this is due tomorrow. Questions, comments, concerns, complaints, compliments, congratulations, criticisms, yes?
Can we get started on the quiz?
It's 9:15. We are out of time. That's all you have.
Don't forget to like and subscribe.